Okay, in this video we're going to take a look at we're going to show that the derivative of the exponential function is just itself. So let us write down what we want to show. We want to show that d by dx of e to the x is the same as e to the x. There are different ways of showing this, but the method I'm going to present you here is quite elegant and a bit easier also to remember. So if we remember, the exponential function is defined as the limit as n goes to infinity of 1 plus x over n to the power n, right? So if you want to differentiate the e to the x, then we have to take d by dx limit as n tends to infinity of 1 plus x to the n to the power n, right? That's the derivative of the exponential. Now you notice we are differentiating with respect to x, and the limit is in n. The limit is in n. So we can exchange the order of these two operators, and we then basically have the limit as n tends to infinity of d by dx 1 plus x to the n to the power n. And now this is quite simple actually, yeah? We have to just use the power law and the chain rule. So this is the same as limit as n tends to infinity of, the n comes down, so we have n times 1 plus x to the n to the power n minus 1, and then we multiply that by the inner derivative, which is just the derivative of 1 plus x to the n. The derivative of 1 is 0, plus the derivative of x to the n, x over n, is just 1 over n. So times 1 over n, and we're almost done. Basically what we first notice is that this n here cancels with this n over here. So what remains is the limit as n tends to infinity of 1 plus x over n to the power n minus 1. One could say that one is already done here, because as n tends to infinity, n minus 1 also tends to infinity. So this is the same as the exponential function e to the x. But to be a bit more rigorous, what we can do is we can write this as the limit as n tends to infinity of 1 plus x over n to the power n divided by 1 plus x over n, right? And now, because this is basically the same term here, but I have the power on top is n, and I have one negative power. So what I did was I used the fact that a to the power n over a is a to the power n minus 1. So this here is exactly the same as this over here, right? And now what we notice is that if n goes to infinity, x over n goes to 0, right? So this is just going to be 1 plus x over n to the power n divided by 1, which is just 1 plus x over n to the power n in the limit as n tends to infinity. In the limit as n tends to infinity. Forgot to write limit as n tends to infinity. And that's it. That's the definition of the exponential function. So we saw that the derivative of the exponential function is just itself. Now let us do another example. Let's calculate d by dx e to the ax. Now here what we do is a is just some constant and x is the variable with respect to which we are differentiating. So this is just going to be e to the ax, right? Using the chain rule, first we differentiate e to the ax with respect to ax. So that's just e to the ax times, and then the inner the derivative, which is just going to be the derivative of a times x. So that's just going to be a. So this is a times e to the ax. Yeah. So yeah, that's all I wanted to show you. Please like, share and subscribe, and I'll see you in another video. Thank you.